Now that we know we can connect the dots on XT graphs, we can see the motion of the car in a clear, visual way. But not all XT graphs look the same. Let's explore a few different types to understand how they represent different kinds of motion. First, let's talk about a graph that represents a parked car. Imagine the car doesn't move at all during the measurement period. The initial position would be 0, and the final position would also be 0. On the XT graph, this would look like a horizontal line right at 0 on the y-axis. This flat line at 0 means that the car stays at the same spot the whole time. It's not moving at all. This type of graph is called a zero line. Next, imagine the car moves to a new spot, say at milestone number 5, but doesn't move any further during the measurement period. On the XT graph, the car's initial position was milestone number 5, and it stayed at that same position throughout the measurement period. This will still look like a horizontal line, but instead of 0, it's at milestone number 5 on the y-axis, since the car remains stationary during the measurement period. This is called a constant line, just like the 0 line, but at a different height in the y-axis. Next, let's go back to our example, where the car is traveling at a constant rate of 1 mile per minute. On the XT graph, we know it looks like a straight line sloping upwards. Since the car is moving at a constant rate, the slope of the line is steady. For example, a slope of 1 mile per minute means that for every minute that passes, the car travels 1 mile further from its starting position. This type of graph is called a linear line, and it shows that the car's position changes at a uniform rate over time. A similar situation happens if the car moves backwards in a constant rate. For example, let's say the car starts at milestone number 10 and moves back to the original position. The line on the XT graph is still linear, but this time it slopes downwards.